Good evening, everybody. Another session of Adda. Almost punctual. 1 minute late, I think. 7:31. Yeah. Hey, Dishupriyo, Sahil, fantastic. Okay. So today's guest is somebody who's not really from my field, but from the time when I was a child, and something about the sky, the night sky, have always fascinated me. What's there, the world beyond, the stars, the planets, the galaxies. I remember I'd gone to Nehru Planetarium to see, like all the kids do, to see the constellations in the dome. But yeah, something incredibly interesting about the world out there. But I had nobody to ask these questions, and my academic scores were not too great to ask these questions to anybody. The coincidence is that very late in life, I realized that my childhood friend is now pretty much one of the youngest dynamic astrophysicists, cosmologists, whatever you call it, in India. He's working in cutting edge of technology, and we actually played cricket together in school, where Pada, actually, our colony. And hi Shilit, hi Atushi, they are all our ardent fans, always come first. Awesome. So never discuss science and never discuss, of course, academics in a cricket ground. But it's amazing later on when I realized that Professor Tarun Souradeep is the same Tarun. We used to call him Bubul. I was like, oh my God, this is incredible. And I'm extremely, mom is there, Ishita, awesome, lovely. So, we had a colony called Patel Nagar, East Patel Nagar, and it was like a family. Who was getting what marks, who was brilliant in what, nobody cared. It was just like we had a party. But when I got to know that this is the Professor Tarun Ghosh, I was like, oh my God, same guy we used to play cricket with. I used to bowl him out, or he used to score me for 4. And I'm so happy. Again, we renewed our friendship, and we've been doing a lot of work together. But more importantly, kind of constantly hound him with my sometimes very crazy questions. And I just thought that it's fascinating that how the world of science and how the world of music, there are many things in common. So without wasting time, I will quickly call in my next celebrated guest, Professor Tarun Souradeep. Hi, Tarun.
Hi, Shantanu.
Fantastic. Tarun, I can see a beautiful photograph behind you. What is that?
That's the rendition of the LIGO India project,
Okay.
Which will be set up in Hingoli.
Okay.
And this is based on actual architectural drawings. So,
today what we'll do, Tarun, is that you will say stop, and I'll constantly try and simplify it.
Okay.
Okay. So before anything else, Professor Tarun Ghosh is now your chair physics in ISR. Is that it?
Yes. Chair of the Department of Physics.
Yeah. So ISR really stands for Indian Institute of Science, Education and Research. And also he is pretty much one of the forefront of LIGO India project. And LIGO stands for Laser Interferometer Gravitational Wave Observatory. Am I right, Tarun?
Yes.
Yeah. Okay. As we go further, we'll talk about these complex things, but let's go to Pada. Let's go back to childhood. Let's go back to when we're growing up. Tarun, I still remember we were all a huge fan of your father. Moa, hello. Fantastic. Indra, hi. Sonali, hi. We were a huge fan of your father. Let me tell the audience that Tarun's father was one of the finest cartoonists that I have ever seen. His drawings were amazing, and he was a celebrated cartoonist. And what is amazing is I still remember an incident. Early morning, he came to our house and told my mom that And he was always like that. He was like,
Yeah.
he was there. So, and he sat in the balcony because there was a beautiful Krishnachura's gach, and a lot of birds would come. And he spent almost 2 hours in the morning sitting and observing the birds. And before going, he sketched a bird and gave it to my mother and went away. This is the man we know. Tarun, tell me about him, and what were the influences that you think you have got from him?
No, my father was amazingly multifaceted. I mean, so he was, of course, very renowned cartoonist for a decade and a half. For dailies of Kolkata would run his cartoons, 3-4 of them every day, and then. But he has an interesting distinction of making the first animated film in India,
Oh,
way
oh
back
wow.
53. So it was called Michke Potash, like
Okay.
Mickey Mouse kind of stuff.
Correct.
Very unfortunately, the whole print got burned down with the fire in the there was this theater,
Okay.
theater. The name skips my mind right now.
That's okay.
But
So while you're talking, I'll just this is one of
so
beautiful sketches. This is Hemant Mukherjee.
yeah.
He would actually go to these concerts, sit down, and with nothing, he would just paint something and give it to the artist and come back. It was incredible personality.
Shantanu, I've seen him do this right in front of our eyes.
Okay.
Things like this would take him 15 minutes.
Amazing.
I mean, this one is, of course, brush and thing, but the pencil sketches, there's something where it's amazing that he would sit while chatting with the person and then, present that person.
Like this is a beautiful one. Indira Gandhi, am I right?
Yes, this is
amazing.
So he was extremely good at caricature and animal drawings, and kind of. So actually, my father's cartoonist, the famous period, essentially almost before I was born, right? So when I came in, he was already had done his big innings as a cartoonist in Kolkata, and when I was 2 years old, we moved to Delhi. And he moved to Delhi on the invitation of Shankar Pillai at Children's Book Trust. And then he spent a lot of time, illustrating children's books.
Okay.
And they are amazing. So anyone who can look up the CBT, Children's Book Trust books of the 70s, I find some of the prints are still available on arts, sites. In fact, so I just managed to buy some of them because there's no prints there otherwise.
Correct.
And they're amazing. So some of them are very, very.
So the reason why I wanted to just introduce you through your father was that many of us have this misconception that if you have a brilliant kid who loves science, there must be somebody in the house who is a scientist or as brilliant. But what has surprised me is somebody who is absolutely a different person in terms of what he did, and from there comes Professor Tarun Ghosh, a brilliant artist's son. And I think that is the magic of life. Yet, I think as we go further in the conversation, I will prove it to you how science and art are together.
Right.
So I'll fast forward your school, and now you're in IIT Kanpur. Okay, what are you studying in IIT Kanpur?
I went there to do mechanical engineering.
Okay.
So IIT was a very strange story for me. I mean, nowadays, of course, people prepare for years. For me, IIT was something till the class 10th. I was not known to be good in mathematics, at least in my family. My brothers were very good in physics and math.
You mentioned your brother. I just want to say that Orunda is here. And he's pretty much the guy we have looked up to. So big shout out to Orunda. Big shout out to Sharda, Rashmi, Shariva. They're all here. So a lot of known people here, and I'll keep on shouting out the names as we go across. Ashish, Keka, Madhumita. Yeah, go ahead. Sorry. Yeah.
Yeah. So essentially, after 10th, I changed my school to prove to my brothers that I could do well in maths in the school that they studied in 11th and 12th. And that was transformational. Like when before that, I remember one of my brothers telling my mother, look, I mean, maybe he should do. I used to write very well in class 10th. In fact, my teacher used to ask me whether I wanted to go into journalism or writing and things. So I used to write in English, but so that's quite transformational. So my whole thing was I wanted to do well in maths, and then I got very fascinated by maths, physics, and I did well. And IIT wasn't my first dream. I was actually planning to do line in physics, like many of the seniors. So this, I think, the para. I mean, our colony, because of National Physical Lab and things like that, had a tradition of many people of the very bright students doing physics.
Yeah.
And they are. I mean, Abhijit Shah and University of Arizona is one of the top.
And you must also mention Dr. Mitro.
AP Mitra and Adda, and so there was a whole aura around physics.
Yeah. Thank God I didn't know all these guys' academic qualifications. Thank God. Yeah. Okay.
No, it's not that I knew also. At that time, they weren't bothered about these things. But I think it sort of plays on your mind, because I remember my brother, who's an architect, who shouted out too. Even he had this feeling that he might want to do physics in St. Stephen's. I don't recall, but I think after joining School of Planning and Architecture, he even was considering coming to Stephen's. And I did the same. I interviewed in St. Stephen's, even after getting IIT Kanpur.
Oh, wow.
Yeah. So, but IIT Kanpur was very good. It was amazing because, that's the thing I always tell the students. It gives you opportunity which is absolutely different. At least in those days, there was no other place which gave you so much opportunity. There's so many clubs you could work with, so much, beyond academics. So if you did not, and I decided very soon that I did not want to be a 9-pointer. I said, okay, fine, I will do some well, but but I joined all the clubs. I was part of the astronomy club, ham club. Then there was some martial arts. Then gliding was amazing. So I actually did many lessons in gliding. Came very close to.
You have somebody asking you this question. That Tarun sir, are you by any chance from Raisina Bengalis?
Yes.
Yes.
11th and 12th. Brother studied entire school in Delhi times in Raisina. I joined Raisina in 11th, 12th.
Okay, so from mechanical engineering to physics and higher physics and astrophysics or whatever, are you being judged? Are you looking at people looking at you like, is this guy gone mad? What is he doing?
Oh yeah, I mean there was some of that. Not in my family. So this is where I would say, you kept asking me, where did your father play a role? He played a role by just telling us what's good, but never told us what to do.
Correct.
Right. So for example, I remember when I left my job, after engineering, actually, I was in the automobile design, an industry. 6 months into it, I came home with a gift, and it looked like a Christmas gift or something. I said, no, look, I gave up my job. So, but there was absolute celebration at home. So I did not realize that, this was something that everyone in the family realized, much before me, that
Absolutely.
I wanted to do something else.
So before I ask Tarun for the questions, let me just wow many of you guys who are not from the world of science, is that I'm going to play you a soundbite, okay? This soundbite is the sound of wind in Mars. Basically, the solar panel is attached to a seismometer. It was not supposed to record sound, record Martian earthquakes. but the sound of the wind hitting the panel created the sound. And let me see. So basically, most of the sound initial part is in low frequency. Just wait, it'll come. Can you hear? This is the sound of the wind in Mars. Can you believe it? Yeah. So my next question.
Actually, I will have something to say about that when we discuss.
Of course, of course. So my next question is, how fantastic is the world up there, Tarun?
Yeah. So you get into science. It's just like in art. There is a period where you're picking up tools, and you're looking at things, exploring, and slowly, when you are well into it, you start wondering what is it that we are working with. So sometimes the kind of things concepts that we work with are absolutely mind-blowing, right?
Okay.
The universe is unbelievably big, unbelievably rich, and I think what is most amazing, I think it's absolutely a tribute to human intellect, that sitting on this tiny speck of dust in the middle of nowhere in the universe. Our
Absolutely.
galaxy is just an ordinary galaxy. Our star is just an ordinary star. I mean, sun is just. On
Correct.
that speck, we are sitting here, and we can figure out how the universe must have begun, right from like microseconds. Like I don't know whether people know this word, attoseconds, right? So this is like one part in many
Correct.
billion.
Correct.
And we know the entire history, and we have figured it out by observation. So that's amazing. And what we discovered in visually is unbelievable. I mean, I'm sure many people enjoy the astronomy picture of the day, or beautiful pictures of our own galaxy.
Hubble. Through Hubble. Yeah.
And these have really been showing to us how small the world is, that we are completely obsessed with, and what is out there. I mean,
Can you talk about this photograph?
Oh, yes. So this is one of the deepest images taken in the universe. So you've pointed the Hubble at one of the vacant parts of the sky. If you peer deep enough, you see galaxies. And even the smallest splotch here is a galaxy. And some of them, if you were to look very carefully, seem to be very irregular, not like nice spirals and well-formed. These are galaxies which are forming. So light has taken so long to come from them that we are seeing them when they are forming.
Unbelievable.
When we look out into the universe, we are looking back in time. See, when I see the sun as it was 8 minutes ago. If magically the sun disappears, I will know 8 minutes later. Right. So similarly, when I see a galaxy far away, it could be billions of years, in the past. Yes, it's like the fact that light cannot travel faster than a particular speed. Tells you that anytime you look far, you're looking back in time. And with light, we can look back to a time when the universe was only 400,000 years old.
Correct.
And there's a beautiful glow out there at that time.
Yeah. So I pulled up this photograph to say that we were talking about how small we are. And when you see this photograph, you realize how even smaller we are, and how even consequential we are. Yeah. And I think that is my next question to you, Tarun, that how do you deal with something which is so small?
Yeah, so it's amazing, right? So there are people who have really spent their lifetime very, very,
we'll say a quick hello to Miladi. Miladi is here. We're talking about Dr. A.P. Mitra, one of the pioneers in the world of astrophysics, and his daughter is here. We were all part of the same para and the same colony. Can you believe what an incredible colony I was part of? In spite of that, I couldn't do well in academics, but thank God, Tarun has been amazing. Yeah, Tarun, continue. Yeah.
So, for example, one of the questions a lot of people have in their mind that we are on Earth, we have life as we see it.
Mhm.
Is there intelligent life?
Mm.
And the question that immediately is, how many habitable planets could be there, right?
Correct.
Now we started hunting for planets. That's been something that's been happening for the last decade or few. I mean, I'm pointing to that because last year's Nobel Prize was given in that area.
Okay.
First
Okay.
detection of extra
Mm.
polar planet of Earth-like planet,
Mm.
and you realize that all the about 4,000 planets have been detected in others around other stars,
Mhm.
and there we are only looking at our absolute galactic neighborhood.
Okay.
Okay, maybe 1/10 of the size of our own galaxy. So if
My
you think
God.
4,000 there, imagine how many are there in our own galaxy. And we know that there are billions of galaxies. We see them.
Yes.
So how unlikely it would be that nowhere there was a habitable planet where something that happened on
Yeah.
Earth did not happen.
Yeah.
To me, it's unbelievable. If you
Absolutely.
have this thing of thinking humans are the thing, right? We are
Yeah.
anthropocentric view.
Yeah.
This is
Yeah.
where it's obvious that we are one of
Many.
billions
Yeah.
of
Yeah.
intelligence out there.
Hmm. Okay. So one of the things that guys, today I know there are a lot of questions coming in. We'll have to find out a way where maybe you can send this to me by mail because we can't accommodate everything. Ideas to like ganne ka juice, chuso out Tarun, what's inside him. But okay, here is the part where I introduce the music now in the thing. Tarun,
Yes.
when I compose, what happens is that I have a fantastic idea. This fantastic idea is not based on anything cognitive that I've heard, but it's there in my head. I can hear oboes, I can hear strings, I can hear cellos, I can hear a beautiful tan, I can hear a tanpura, and I'm designing it in my head.
Mhm.
Okay, it's all happening here. It's nothing here. Now, what happens is that once I have visualized it and I can hear it nice and clear, I now start working towards collecting tools which can bring me closest to this imagery which is I've envisioned in my head. How different is your subject or how similar it is to my process?
So the process of thinking is very similar. So again, maybe I came from this background where I see no difference in the way an artist creates and a scientist creates at the top level. You have to imagine, you have a picture,
Mhm.
then you have to see what kind of branch of science that you have to use to
Mm.
convert it to equations. So the only thing is, instead of using a paintbrush or your cello,
Mhm.
we use equations, we use computer codes. But
Correct.
overall, whenever I have many of the projects are ideas that just come to you,
Mhm.
oh, wouldn't this be nice, this symmetry could be measured. Okay, and then you start working towards this, then you read up books and then try to see, where are these ideas,
Okay.
I find a connect. And
So in music, what happens is that sometimes fantastic thing that I have created, finally what comes out may not be there what is there in my head, but it is not something bad either. So
Mhm,
it's a little shift from what I was seeking out for.
right.
What happens in your field?
No, so it often happens that your idea doesn't go through. So maybe
Mhm.
you just find that you had this idea that you could come up with this, you know, say calculation or some kind of a, formalism, and then you find it doesn't work, or it doesn't work the way you wanted it to. That's
Correct.
often the case. And often in science, there's something else also, where it has to ultimately explain reality.
True.
Of course, but there are areas of physics where people have gone out, where they have developed formalisms, maths, beautiful structures.
Mhm.
The question ultimately is, does that correspond to reality? Is that explaining reality? Our whole idea is that we want to model reality,
Ah.
and that is the basic.
That is where you and I kind of,
Yeah,
yeah,
there's the guillotine, right?
yeah,
So you can
yeah.
have the most beautiful theory, and it could be not supported by nature. Has not chosen to be that way. I mean, one big example a lot of people may be aware of is they know
Mm.
that I started my learning under Professor Nallikar, Jayant Nallikar,
Correct.
and
Correct.
he was the person who proponent of the steady state theory,
Mm.
and that's
Mm.
based on a beautiful symmetry that the universe is unchanging in time,
Mm.
right? And
Amazing.
to explain that, so, but there are observations. There soon came observations that make it very untenable, right?
Absolutely.
However, that's the you can see by the name of the thing. There was something called a cosmological principle, on which cosmology models are built. This was built on what is called the perfect cosmological model, uh,
Mm.
perfect cosmological principle.
Mm.
Right? Yet, nature did not choose to go that way.
I was just telling you about a fantastic idea, a musical idea in my head. Tarun, I think what both you and me are struggling with in our worlds is that how do you make somebody see what is there in my head?
Mhm.
Now, I'll give you an incredible example. If 50 years back, somebody would have said that this is not a child's playing with colors,
Mhm.
this is
Right,
the stellar nursery, these are stars being born, am I right?
right.
Who would have believed it?
No,
Who would have believed it?
exactly. So it's amazing the kind of pictures, even in our childhood, we have never seen pictures of this kind,
Correct.
right? So I keep pointing out to people where, in like when you want to get kids excited
Mhm.
and you show them Jupiter or Saturn through a
Correct.
telescope.
Correct.
Earlier, we used to be wowed because
Yeah.
that was the best way you're looking at a thing. Now I have found children who say, "Oh, but it doesn't look like what I've seen," because they have seen Saturn, pictures of Saturn taken by a spacecraft which was,
Yeah. Yeah.
very close to it, and they see it in
But
detail.
here is my struggle, Tarun, is that this image, I wish there was a way to show my what is there in my head to people who are investing in me.
Yes,
Understand the process, because this is there in my head. Somebody has to believe it, that oh, this is what you're seeing.
right,
That person also can't see it physically. It's almost like a microwave,
right.
where I'm saying something, you are understanding that something. And here I want to do a very interesting exercise with my audience who's out here, just to tell you this whole idea of how do we communicate with two people. And I'll give you an incredible idea how the human brain is fantastic when it comes to especially music. And I've always believed this, that more than the visual medium, the ability to find out something is not right in the oral medium is 10 times more powerful. And I'll give you a small demo right now, and we'll do this together. I'm going to compose two lines right now. You have never heard this before. One line, something is not right. Okay? You tell me, is it line number one or line number two? Just type the number line. Line one, line two. That's it. And let's see. Okay. So my first line is dum dararam dum dum dararam dum dum dararam dum dum dum. Second line is dum dararam dum dum dararam dum dum dararam dum dum. First line again. Dum dararam dum dum dum. Where is the problem? First line or second line? Just type down the number.
Okay.
And then I'll ask you to. Is line one problem or line two problem? Uh, Tarun, what you heard that? What
I
did you feel?
okay. To my untrained ears, line two was
Okay,
a problem.
wonderful. And I can hear a lot of answers coming saying line 2. Now my question is, isn't it fascinating that this information has never ever been received by the audience? Anybody? You have never heard this. I've created it right now. Okay? How did you know that there's a problem with line 2? Because what is happening is, if there was a spectrometer right now, the absolute zero would be what you call is in tune. When you move away from the absolute zero, you know it's not in tune. Either what you call it's flat or it's sharp. थोड़ा सुर से कम लगा है या थोड़ा सुर से ज्यादा लगा है. But it's an absolute zero, which in the modern world, you can see it in the computer, see it in the graph. Right now, what I did, you had none of these tools. You had what is inside you. There is an absolute zero inside your brains, which tells you that this is not correct. And I think that is fascinating. That is just absolutely fascinating that human beings are born with that absolute zero, who can just know, hey, this is sounds good and this does not sound good. It does not. You don't need to have previous database about this. Tarun, comment on this.
No, so this is also probably built on the intuition that you build up. See, we as human beings learn. So you have heard a lot of tunes, may not be this one, and we don't quite understand how we learn, right? So, for example, in science, if you go to very experienced people, and I'm slowly, often a student brings me a result, and I can say there's something wrong, right? I may not be able to point out which equation where, but I say, oh, this cannot be right. Just check it again. And I can tell you most of the times, many of the times I'm right. They go back and they find something. So there is something that you over years accumulate as patterns. So I think human beings basically, like music is a set of patterns of notes.
Yeah.
I think even our ideas of the universe or how physics works are patterns, right? I mean, you see, oh, this is the right pattern, this is the wrong pattern, right? So,
but what is fascinating, Tarun, is, of course, I agree with you, but I also tell you something amazing: that children, absolutely toddlers who can't speak nothing, their facial expression or downright crying to protest when you play a piece of music, and which is one is beautiful, melodious, and one which is harsh to the ears. And I'm not talking about volume. It's I have seen this many times. So there is this. My point here is that man is also been sent. The human species has been sent with some senses. And what happens is, the work that you are doing, you have started believing in those senses, and you started taking claim on those senses. Common men, all of us, take it for granted. You can't take it for granted, and the reason you, because then you can't have fantastic visions like this. This is also still a nursery.
Yeah, this is more close up of new stars being born.
Correct.
And it takes a lot of effort to get this picture, because if I were to go there, I won't see those stars because they'll be shrouded in dust. Stars are born inside dust clouds.
Correct.
Okay?
Correct.
So you won't see them. And dust, by dust we mean molecules in space. A lot of ethanol, by the way, in the universe.
Correct.
So that I think is you expect something like that, and now you can peer through and see those.
Tell me about this. This is so beautiful. This is like art.
Yeah, this is amazing, right? So often that is the amazing part, and and now we have such high resolution maps that you can see very intricate structures, just like as if this would be some oil drop in a puddle, and the colors around it, right?
Oh my God, this is just fascinating.
It's fascinating. It's amazing. But this is a real thing. We understand it as the remnant of a star which lived its full life and exploded, and the material it ejected was spread out like this, right? And every now and then this happens. So what is very amazing to me. And then once I remember talking to my father late in his age.
Mhm.
We used to talk about life and
Mhm.
what does it mean.
Mhm.
And I remember telling him that
Mhm.
human, we worry about death and people dying and all that.
Mhm. Mhm.
Every time a person dies on Earth,
Mhm.
somewhere in the universe, a
Mhm.
star has
Mhm.
ended. So imagine at some point our sun will also end. So
Yeah, true.
catastrophic, right, for us.
Yeah,
And
absolutely. There's
that
another one which I'm pulling up, which is just
now
beautiful,
and
just
then.
stunning. Yeah.
So, and they then leave behind this absolutely fantastic legacy.
Why didn't they show these photographs when I was in school, Tarun? I would have, I would have really
Have no
loved
choice.
science.
Honestly, I didn't see them either.
Yeah,
So, just
this is.
that the boom in astronomy has been technology. That's
Hmm,
one point I keep making. Science
hmm,
grows because of your technological ability.
correct.
Mm.
Tarun, a lot of people have a lot of questions, but one of the common questions that they have is there life out there?
We don't know for sure, but we are looking hard for it. That is a priority. NASA about maybe now almost 10 years back,
Hmm,
essentially just like they had a priority of sending man to moon, finding Earth-like planets is
hmm,
a priority. There are amazing, you know, space missions being sent out so that
hmm,
we can peer deep and follow up on the planets that we have already located, study the atmosphere, check whether the atmosphere is similar to Earth, and then hope that those are the places maybe there's life. Life certainly is there. Life could be even there in our own solar system. There's this, deep feeling that one of the moons of Jupiter
hmm,
harbors life
hmm,
underwater. So it's
hmm,
not going to be the kind of life we see here,
hmm,
but the oceans which are covered
hmm,
are warm enough to
hmm.
support life as we know it.
Just like I told you guys that electromagnetic waves coming from emitting from planets are then converted to uh, digital audio signals, almost like something like which is happening on the phone right now. The data which is there on your telephone is in one and zeros, it's like digital, but there's a digital audio converter which is converting this to an audio signal. That's how you're hearing the sounds. It's not that it's an audio waveform out there, but because he mentioned Jupiter, here is one of the sounds which has been converted from such rays. It's the sound of Jupiter. I don't know if you can hear this. So I mean, it's almost you can hear this almost like a there's a tune out there. I mean, it's just unbelievable for me that and I'm also a dreamer. I dream, but it's almost like how sad it would be if this incredible celestial objects did not create such sounds. Quickly, while we're talking about sounds, I just want to say that I always want to ask this question to a scientist, but you're the right person to ask you. That when I asked you the first question is there life, and you told me, tell me, do you believe in God?
Um, yes, in some sense, there is some order in the universe. Now, whether, I don't believe in a human form of a God,
Mhm,
but the fact that there seems to be some pattern to it, why would the, universe follow simple equations that human beings can write?
mhm.
Which means there's a pattern.
Correct.
We are uncovering such things. Maybe there are things which we'll uncover a century later and we'll say, oh my God, these guys didn't even understand that this was actually the pattern.
Hmm.
Just like we have revised our understanding of physics,
Correct.
for centuries,
Correct.
and biology, for example, right? And
Mhm,
biology probably is poised to a big, thing where we will probably understand the meaning of why things are the way they are.
mhm,
We now know elements. We know that this is what is happening. So there is a phase of science where you collect information. And then you say, like, Darwin went out and looked around everywhere and then saw that pattern and said, oh, there's evolution. Species, origin of species is a evolutionary process. So that was a remarkably deep idea.
Absolutely.
So similar things would happen. And I believe that if everything is so much a pattern, somehow that pattern itself, the mathematics itself, is almost to me as good as God. I mean, it sort of says
Beautifully said.
an equation and I explain everything. Right? So then what is that? What is God? God is all knowing. He knows everything.
Very interesting.
Everything you can derive is there in the equations.
I just moving on from there, I just felt that when you compose music, the act of composing is a very, very vulnerable moment, Tarun. Because you're at your barest, you're going to make mistakes. It won't be right. We're very guarded about that moment. Once it's done, once it solidifies as an idea, then you involve people inside it. But at that moment, Tarun, how important is it for the scientific community to dream?
Oh no! So we dream. I know that there is this feeling, and even among scientists, that we are supposed to be very cut and dry technical people. But I think all of us dream, and at least the best people I have seen are people who can, imagine that this must happen. The fact that they are scientists allows them to translate it to something objective, like an equation or a particular way. But it's a dream. I mean, you dream that I can, say, classify all kinds of shapes.
Correct.
Mathematicians dream.
Correct.
We managed to finish the whole program in 1984. It was centuries old thing of saying all kinds of shapes. And I met this person called, he's a field theorist called Thurston, right? And part of, something called the shape of the universe. We were working on the shape of the universe, whether the universe itself is like a donut or something more complicated. And you can see that now with thousands. You can check them.
Yeah.
And I was discussing with him, and I understood, there were, of course, very rigorous mathematical theorems that are quoted. But the way he was explaining to me was just like, oh yeah, but you see it in any surface that you see. Don't you see this is
correct,
very common? And that is all that is encoded here. And they are called very daunting names like rigidity theorem.
Yeah.
But rigidity theorem is something that I can explain to a 8th standard kid.
Okay.
Right?
Okay.
So that's
I get you. Yeah, I get you. I just, while we're talking about this, Tarun, it's a proven fact actually that musicians, especially composers, when we compose, a lot of complex mathematical equations we are actually solving without thinking it's mathematical equations. Right. If you were to put down those notations as a equation, you will know how complex they are. And similarly, when in science and any mathematics, you have the concept of left hand side is equal to right hand side. Basically, you're equating the both, and there lies the fantastic. Okay. Yeah. Now, what happens in music, which is incredible, is that we don't have any left hand side and right hand side. We have coming home. What coming home means? For example, I'll give you an example. So my note is this note is my coming home. Okay. Now I'm composing. I'm not playing anything. It's just I came back there. I didn't require any credits. This is the incredible part of the human brain, that it knows where do I have to reach. What is my homing facility? What is my GPS? How do I cut through billions of neurons and come back to that one note, which was important? And I think that is so fascinating about the arts, is that without knowing, you're solving
Yes, you
Complex
accomplish what
equations.
we do with, we try to explain that. See, there are people who are working on that, right? Similar ideas of how are notes and why is something more harmonious than others. They
Correct.
try to quantify it in terms of sequences there.
Correct.
And this fact that, you're coming back
Hmm.
to what we call cyclic symmetry,
Correct.
right? Something that repeats. And, there's a whole branch of mathematics on these cyclic symmetries. I mean, and
Correct.
many things depend on that. Entire particle physics, our understanding of the most fundamental particles is based on essentially an extension of this idea of cyclic things. I mean, symmetries. Like if I keep changing, using a particular translation, I'll eventually come back to this.
Okay.
Otherwise, it doesn't form what is called a group.
No, I get you.
Now, these are very technical terms, but they are very similar to what you're saying.
Yeah.
That
Yeah.
your harmony, in some sense, if someone was to look at it, maybe there's, if you put it in the mathematical terms, you'll find that you are working within a set of transitions that always have to come back to itself, which is called an identity transformation.
Okay.
And that has to be part of and a group has to have that by definition in mathematics.
The next question is maybe a little tricky, but if you were given a one-way ticket in one of the galaxies,
Right.
you're the only one in the Earth who's been chosen, and it's a one-way ticket.
Right.
Would you take that ticket?
Yes, I mean, but you should realize that to get to even the closest star.
No, that's rationality. I just wanted to know from the point of view that
Of course. I
the
mean,
fantasticness of it.
amazing. I
Yeah.
mean, I personally, I won't say that, but it's of course a one-way ticket. But that's what we are out here for. I mean, we want to discover. And the quest, I mean, I'm sure if it won't be me, but I'm sure somebody amongst us will be brave enough to say, when we have the technology, to say that I will travel to that distant star.
So, do you think one of the problems that we as a species are facing, and this is just a theoretical question, is we want to come back? That's why. Suppose we didn't want to come back, you could have gone further.
Right.
So, it's just a supposition that
Right.
if there was a way of if you were programmed in a way, and I'm not just talking about space, everything in life, we want to come back home.
Right.
But if this home was near, maybe we could have dared and did things much more fantastic in our lives. Sometimes coming back home, which is important, kind of makes it a little safer. I just have this feeling.
It is true. I mean, even as people age, they start longing for their hometown, right? I mean, it's very common. I've seen it in among my parents and everywhere. So there is this familiarity that you feel with where you started your life. But on the other hand, you should also realize the people, have to go out, way out, risking the fact that they'll never come back to
True.
do something beyond, right?
True.
Every step, like even the Apollo mission, for example. I'm
Yeah.
sure the guys who were there knew they had a finite chance of never making it back.
Absolutely. And Kennedy's. I love the opening line of Star Trek. Space, the final frontier, where no man's been before, and I think that defines it. How much of Star Trek is possible with as science unfurls today's date?
That's an interesting question, because Star Trek, of course, many of the ideas there are extrapolations of things that are possible now, right? So all the guns that they talk about, they're similar things. I mean, we know that if we can pump such kind of energies, we can vaporize a person, right? If you stand in the path of a powerful laser, you will actually suffer what those guns are doing. Now, of course, those are becoming not unreasonable.
Correct.
But you also have this thing that is called warp drive, right?
Yeah.
It will just go at any infinite speed. And I teach that to students in my GI course and tell them what it means. And it is actually, in principle, possible. If that's the way to contract space in front of us and expand the space behind us, we will travel fast. Okay. And
give them the example of that kid crawling on a carpet. I
oh,
think that's a good example.
the point is, the kid. I mean, so basically, you
So
imagine.
guys, this is science demystified for you guys. So that's why I find this example fascinating.
Carpet at the end of it, you have put some treat for a baby, and the baby is trying to crawl, and its crawling speed is finite. So if it just simply crawled, it would. But suppose the baby was powerful enough to pull the carpet in front of it, fold it up, and move. It will move towards its target much faster.
Correct.
Right? And something amazingly similar happens because the universe is expanding. We are only 14 billion years old as a universe. The universe is 13.8 billion years old. But light has, from the most distant light that we see, comes from a surface that is 42 billion light years. Which means you have already, because of this space being smaller in the past and now bigger, you have already gained a factor of 3, right? What you have covered.
Audience, while you're listening to this, can you quickly type how many zeros are there in billion? This is the question.
Billion,
I don't know. No, you don't answer. Let the audience answer.
Okay. Sorry.
Yeah, sorry. Go ahead.
Yeah. So
okay. So a lot of questions. One of them asking, Tarun sir, do you think there are aliens?
Yes, I mean, if there's intelligent life, they're intelligent enough. We would call them aliens. Of course, there would be. I mean, it's very unlikely that we won't have at the level of bacteria and lichen kind of simple life forms.
Yeah.
Okay.
It's complex.
I think I wouldn't be surprised in my lifetime if we go to Europa and find it, and it won't be surprising to me. I completely find it difficult to imagine that somehow we were the only people in this world. It's so lonely. A thought that you are in the middle of such a vast cosmos and you're the only one who can think.
And with our below poverty line intelligence, if we are the only ones thinking, then I think there's a problem.
Yes.
I definitely feel. Also, the biggest problem I think is that why do we feel that alien is going to be a creature which is like and all that? It could be wonderful. Why are we assuming that there are people worse off than us?
No, exactly.
We could be pretty much the last person on the food chain, in terms of how bad we are. Yeah. So they could be wonderful people. They could be what we call angels. Who the hell knows?
No, I think it could be anything. And also, if a species is intelligent enough to have survived long enough to be more intelligent than us or have more knowledge than us, that knowledge has to be capable of not self-destructing.
I got a question from
we are facing as human beings.
Correct.
People talk about climate change, and are we sort of being so successful that we're killing ourselves off?
Absolutely.
Right.
Absolutely.
Smarter civilization would not. If they have to survive a million years, then they would not have killed themselves off.
Tarun, now tell me about LIGO.
Yeah.
The thing which gives you the biggest smile and is the most exciting thing which is happening in your life. And while you explain it, I also want you to play that sound bite.
Okay, so let me tell you that the universe is full of stuff moving around, right?
Hey, I got a lot of answers. Rupa, Sucheta, that's cheating. Sucheta, you're a mathematician, brilliant mathematician. You obviously know. Sucheta is Tarun's wife, and brilliant mathematician. Welcome her this thing, and one of these days I'm going to have a session with her about she demystifies mathematics for kids. She's amazing, and I think actually she should actually do these kind of sessions to really talk about how mathematics is not, oh my god, and people like me have suffered and can be fun. Anyway, so yeah, you were saying about LIGO.
Exactly.
So guys, listen to the sound, okay? High frequency sound coming up.
I will play it again, or maybe it's already playing. I don't. Yeah.
Did you hear that? Did you hear that? Give me a thumbs up on the chat. One more. Give me one more, Tarun.
Yeah, so they will come one after the other.
Yes.
And you can see the notes changing. So for a
Yeah.
musician, you can see that you're going into deeper notes. And this has to do with the masses of the objects that are moving.
Amazing.
All objects move, they have a whine, and then it's called a chirp. And this is a series of chirp as big, massive dead stars, merge into each other. And this is what LIGO measures. We measure the gravitational waves, and if you translate that to sound, this is how it actually would sound,
Wow.
right? And so to measure this requires instruments which are unbelievable, which is what is most fascinating to me. You need to measure the width of a hair, that kind of a difference when you're measuring the distance to the nearest star, right? So accuracy, you are demanding that kind of accuracy. Here it is a 4 kilometer arm, and the separations change when one of these sounds play is a part in a billion, right? 18 zeros,
Jesus
right?
Christ.
And it that amount is smaller than the size. Everyone knows that there's an atom. An atom has a small nucleus. It's 10,000 times smaller than the nucleus, and we are measuring that. Okay, so that is fascinating that we were capable. It took a century to come to this, right? We knew that such things would happen with Einstein's theory of gravitation, and then,
See, that's the part I like. You knew that such a thing would happen.
right,
As I said, that I knew that I could come up with a tune. Piyu bole, piya. It's a belief. It's a faith. It
right.
comes from an instinct, just like in science.
Yes, but here, it's an amazing story. LIGO, so the idea that these waves exist was there, and in the late 60s people solidified that idea and realized that could be measured, and soon immediately people got onto it. So Ray Weiss, who I interact I've met many times, he's the person who won the Nobel Prize, who designed this apparatus to measure,
Oh.
and in the 1970s.
Mhm.
And then to get to prototypes, then this, it took 40 years of quest to get the technology right, so that we could measure the sounds. Now we measure it routinely. We have tens of such chirps or such sounds that we have measured and interpreted in terms of what size of black holes are merging, or what size of neutron stars are merging. Neutron stars, by the way, are very exotic objects. A gram of matter on neutron star, if I take a spoon of matter, sorry, on the neutron star, it would weigh the same as the Himalayas, entire Himalayas.
What? A spoon of neutron,
Neutron,
weighs-
yeah, neutron star matter
yeah, is
is
will weigh as much as the Himalayas.
same weight as the entire Himalayas, right?
Oh my God, this is
So a
just
neutron star
mind-boggling.
has, all the mass that a sun has, our sun has, packed into the size of a city, right? 10 kilometers, even smaller than a city,
Wow,
right?
wow.
So this is the kind of densities, but that's not the most exotic object. Then there are black holes,
You
right?
know, I've
And
always
we are looking for these, and I think it's an amazing door opening to our understanding of the universe with through gravitational waves. And this was a revolution waiting to happen, and I think we caught it at a good time. So around the, to 2007, 2009, I started getting people together on what would be the frontier in 10 years' time.
so I was about to ask you that how did you figure out that how did you smell this subject?
Yeah, so I smell this from the experience that I had. I'm very fortunate to work with Varun Sahani as
Mhm.
my supervisor,
Mhm.
and he had just come back from Canada, and he knew there was certain thing that you could compute. which would be important in the light of the discovery of the cosmic microwave background fluctuations. I told you there's a globe coming from 43 billion light years away. It has small fluctuations.
Yeah.
And we did some work at that time. And then that field just took off, right? So I realized that moment such a momentous discovery happens, things take off. And then, of course, when I came back as a faculty in 2000s, people talked about, why don't you build an experiment for cosmic microwave background? This is something still on my mind. But I also realized that you have to prepare well in advance, which is often not the case here. And we started looking for, I started talking to people about a frontier that will open up 10 years ahead, and then put energy, bring people together, and you have to keep them motivated. See, someone kept this entire team of 1,000 engineers and scientists motivated for 40 years, or a good part of 20
That's
years.
fascinating about science, because in my field in music, if I've delved on a tune for a month, I'm already fatigued. And you're talking about 40 years of an idea, which is like just mind-boggling.
And people coming together and people making tiny. So, the people often wonder why these papers from LIGO, the Gravity Wave Observatory, have, close to 1,000 authors.
Correct.
That's because they appreciate the fact that even the guy who made the slightest change which improved the instrument deserves it, because, that is all that maybe was required to detect a particular signal that we would have otherwise missed.
So Tarun, I think one fantastic thing which is happening in your subject, and especially in this high-end science, is that the world community has come together to work on a common problem, rather than your and mine, and I will not tell you, and I will not tell you. Am I right?
Right. So I think one of the reasons when I went around talking up to people, like, at the planning commission level, then I used to always have a line which says, what is unique about our proposal is that we are relying on global cooperation, not global competition, which is the case in high energy physics, is to be largely the case, because Europe had the accelerator, and then US had the best accelerator, then Europe again had the best accelerator. So it keeps, there's a tussle. But in this game, gravitational waves, you have to all work together as a network to succeed. So everyone wants LIGO India as much as they love their own instrument, because this
there's a question from one of India's great sound engineers, Vishwadeep Chatterjee. When is the James Webb Telescope likely to be launched?
So the latest I heard is towards the end of 2021. It was supposed to be April 2021, but there's a COVID-related, pandemic-related delay that has been factored in.
Okay.
But it's well on the way. I mean, I have a colleague. She works in the Space Science Telescope Institute, and she's one of the really lead people looking at calibration of various instruments on that. And so I keep getting information that this is going extremely well.
Awesome. 2-3 more quick questions for the audience who were asking me. Simply, what is black hole, Tarun? We keep on hearing this for the last 20 years, 25 years. Yeah.
I told you, it's even more exotic than neutron star, because neutron star, at least we know neutrons exist. We have seen nuclei of, within atoms, and we can imagine them to condense into a, under gravity, in a single ball. And of course, we don't know everything about them, but it's actually feasible. Black holes started off being a solution to Einstein's equations. Okay, and as I said, for 50 years, people didn't know whether it was just a solution, right, which does not correspond to reality, or was there some reality to it? What is a black hole is this space is so curved there that if light is sent out from within a black hole, its straight path, light always travels in straight path. The straight path is,
curved.
It's kind of bounded. Earth actually around the sun in Einstein's is moving on what is called a straight line, but in a curved space. A curved space, like on the surface of a ball, or on Earth, for example. the longitudes are actually great circles are straight lines. But they are not straight in the sense of straight. But
ruler वाला straight नहीं है. हाँ.
yeah, they are not straight like a rod.
Yeah.
You can imagine, it's very easy to tell you. The whole definition of straightness is I take a compass in my hand and start from the equator and start walking north. I will walk on a great circle to the North Pole. And someone else on another part of the equator starts doing that. He or she will also go there and we will meet. So this was known to be a problem in Euclid's, basic geometry we learned. It told us that parallel lines never meet. But that axiom was always suspect. And that only works on flat surfaces. So on a sheet of paper, yes.
Okay.
But on the surface of the earth or on the surface of a ball,
yeah,
straight lines do meet.
Wow.
That fact that they're coming together, is as if there's a force. You might think, instead of thinking that you're walking on straight lines, you might think, oh, I believe that we should have never met. So the fact that we met is because of force. In the context of space-time, this is exactly what is happening. Force of gravitation is not a force. Every particle which doesn't have any other force acting on it is moving on a straight line. The fact that they intersect or they change their separation, we attribute it to a force of gravitation, but it is actually just a matter of geometry.
Brilliant. There's maths for you. My mother was asking that in every session you sing a song.
Yeah.
What will you do in this session? So suddenly I remembered one, just because. So I had a song. I had a movie called Eklavya, in which there was a song that Swanand had written. That's the only closest to a celestial object I have ever composed something. Chandare, Chandare, धीरे से उसका हौले से पलकों में छुप जा हौले से बादल के झूले में उसका चंदा रे पलकों में छुप जा हौले से पलकों में छुप जा. There is another amazing person who is watching this live, who mostly all my lives he watches. Tarun is Gulzar Saab, who is he's done his PhD on Chanda and Pluto. So I think he will really appreciate the fact that we have spent so much time actually scientifically talking about it. Tarun, one of the final questions. We have spoken for more than an hour. What are you searching?
I'm searching for, of course, we are all searching for an understanding of nature. But I also believe that to do that, you have to build up the tools to do that, technology. So my latest, the craze that for the past decade has been to bring up in India the level of technical capability required to do frontier science.
Wow.
Okay, and that has been the LIGO India project is one example. I also recently proposed a mission to Prof, measure the cosmic micro background. All of these, I think, you have to take the bull by the horn. You have to say, okay, I will do this, build the teams around it, and it's going to be hard work. But there are people who have done that, right? There are countries who need to learn, and that's why every now I never miss an opportunity to talk to young students, because what I am trying to do is to make sure that there are enough of them excited about this, that they see this as a passion.
Yeah. Right. Tarun, I don't know whether you will go or not, but if you're not going to any such fantastic galaxy, There are 2 tickets, one for me, one for Gulzar Saab. Anywhere in the cosmos, we are ready to go. We are the
Okay.
first passengers. I've been sharing with a lot of sounds with you guys. This is one from the. This is the Earth. So this is the when the it's rotating on its axis. This is the sound. I'm just fascinated. I want to do an album with these incredible sounds. But Tarun, thank you for coming and doing this. A lot of people were wondering that what kind of conversation will be this, but I think I really enjoyed myself because
So did I.
I realized so many ways the way I think as a composer. So much has to do with the way you as a scientist also approach a subject. One final thing, which is my failure, is that I'm unable to conceive what are there in my head, or the audience does not like what I've created. What would be your disappointments as a scientist, or your failures?
Yeah, so whatever you work on does not really capture what is really happening in nature, right? So our judge and jury is, what experiments tell you. So you might come up with something and expect some effect, and if you see it, of course, that's absolutely fantastic.
Yeah.
Most often than not, you're likely to not see it, right? But still,
You have to attempt. Yeah, you have to reach for it.
right.
A lot of mothers are here. I can see in the chat, and one of the questions they keep on asking, you very rarely do I get an eminent scientist like you. How can you make science interesting in school, Tarun? That's the biggest problem. Children absolutely hate the way maths, and they hate maths. They hate where are we going wrong, and what can we do?
I think what I mean, my thing, I mean, it's evolved over time, but one of the things that I realized very early when I joined as a faculty is what our education does very methodically is to kill creativity.
Amazing line.
It's
Amazing line.
unbelievable how its creativity is killed, because see, initially when I joined as a faculty in Ayuka,
What a line, guys. Let's all of us applause to this beautiful line that what education does is the way it's taught, it kills creativity. Amazing.
and that is and now ways taught is one thing. Also our attitude, right? We don't encourage asking questions. A kid who asks a lot of questions, they don't get so smart, don't get beyond yourself. I mean, that's what we have been brought up to know, right? You're not supposed to be too peppy, or you're supposed to be very it's looked as impertinence,
Yeah.
right? That you ask a question. I think these have to change. You learn through asking questions, and the whole method should be. And I saw this stark difference between students I had, initial graduate students I had from India and from Iran. Okay, and even a student who came from France to work with me. The big difference I saw is not technical ability. Technical ability, as I keep saying, can be acquired. It can be honed to, whatever levels. Put in effort. You'll still, to be great, you have to have creativity, right? It's true about us artists.
Yes.
Right? Artists, I don't know that much about music, but for an artist, for example, you can be an artist who absolutely has the most fantastic brush strokes, knows exactly what are the color palettes, knows exactly how to mix things, do that, technically perfect. That person might make a very good replica of a known painting, right? But would he be making a Rembrandt, or this is not
Chagall.
the same thing with science, right? So there will be people with technical ability, and they have a role. I'm not saying they don't have a role. Certainly, you have to have a big community from which sparks will come out. But to get the sparks going, you have to start early. You have to encourage people to ask questions. You have to encourage your syllabus should be more, exciting. I mean, maths, for example, you mentioned Sucheta.
Yeah.
Our main struggle is, when our kid was growing up, she was very upset about the way maths was being taught, right? Luckily, we could characterize some of that. But, maths is a fascinating subject if it's taught well.
True.
Right? And fascinating and also accessible subject. But the way we are taught is, such that it sort of puts you off, right? It looks foreign. And that's our style. I mean, we have a very elitist style in India, expressionist. We like to say only so and so can do it, so and so cannot. And we
True.
tell that very early in the childhood, in school, that that boy or girl, oh, they are the good boys. They will make it. You will not. And that is told even to a class 4 kid, maybe.
Yeah, yeah. I was told very early on. Yeah.
Yeah, so that can color your life. I mean, you might be missing out the best people. I mean, Ray Wise, who's this Nobel laureate, was a college dropout. Right? So obviously,
Mothers, please don't give this example to your kids or anyway struggling during the lockdown. But thank you, Tarun, for this incredible insight. Thanks, all of you. Mijumami, thank you. You take care of yourself. Ma, thank you for being there. Everybody. I don't know Shomodeep Da was there or not. Piklu, the whole Patel Nagar gang. And more importantly, Tarun, keep on flying high, keep on doing the impossible, and keep chatting with me so that I can also make science interesting for myself.
Always look forward to new music from you.
Yeah. Take care, everybody. And thanks for being there. Just to let you know that next weekend, I'm having an incredible friend of mine as a guest. Her name is Shubha Mudgal. She's coming for Adda with me. And we'll actually talk about crazy days that we had while creating Apke Saban. So all best to all of you. Stay safe, stay healthy, and be good. Thank you, Tarun. Love you so much. Bye, Suchita. You take care. I want you to take the mathematics teaching very, very seriously. Bye. 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 Bye.
Yeah.